What's up guys, Pavel Křupala here from BlenderFreak.com and welcome to the next part of the Node Editor tutorial series. In this part the final result will be sockets. So finally we will have some sockets appended to our node. We will have a look at the positioning of the sockets, so you can put them on the left side, on the top or bottom, or the right side, it doesn't matter. And we will even fix some bugs. So warm up your fingers and we will get to the coding right now. Okay, so here is where we left off. We got some node, we got some content, and it's time to start creating the sockets. So in our case these will be represented as circles, and we will, for the input we will start in left top, and for the output we will start from top right. Maybe we could add something like possibility to start on the bottom too. But first let's create some sockets. So the way how we are going to create the sockets will be in the node. Here is a node and we pass the scene reference, here some title, and here we can pass inputs. And we can say socket, and third one. So let's have 3 inputs and 1 output. So output equals to socket. But we don't know this class yet because we haven't implemented it yet. So this class will probably be somewhere in node underscore socket import socket, like this. And let's create a new Python file. Let's call that node socket like this, class socket, and define the constructor self, and I don't know what yet, so let's type path like this. And now we should have some sockets inside our node. So let's quickly have a look at the node. Node is initialized with scene, title, then there will be inputs, which will by default will be empty, and outputs by default there will be empty too. So now we can pass that into the class like this, outputs, and in the graphics node here should be the init of our sockets, so self init sockets like this. And we can put it here, define init sockets self, and for now do nothing. So what are we going to do is, once we create sockets, we definitely want to have some representation of the graphics. So let's say self gr socket equals to, and this will again be q graphical item, so qdm graphics socket like this. And let's create a file, the class for it, so new Python file, and the name should be node underscore probably graphics and socket like this. At this class qdm graphics socket, this one will derive from q graphics item. So let's define the constructor again, self parent by default will be none. Let's call the parent constructor like this and pass in the parent. So from pyqt5 qt widgets import everything. This should not crash, QDM graphic socket is not defined and is not defined here. Yes, that's correct, because we need to write from graphics socket import this one, and when I press play it kinda works. So we got socket created and we got instance of QDM graphic socket, which will represent our socket itself. So what we actually do on a path in the constructor in the socket, later we need to add the graphic socket into the scene. So we can either directly pass the scene, or we can actually pass the parent node. In this case I will use the node because we want to keep reference in each socket. We want to keep reference to the node which it belongs to, and the same thing we want to know is the index, in which position on the site the current socket is. So we will start with 0. So let's type self index equals index like this, and we can probably start counting with the positions. So let's say the position will be left top. This will be our constant. Position equals to left underscore top, and let's define what's left top. This will be 1. In case this is left bottom, this will be 2. In case it's right top, this will be 3, and right bottom will be 4, like this. So this way we can store the reference to the node, index, and which position the socket is, and we can even specify the position, which position should be the socket moved. So if we go to the graphic socket, we can start slowly creating our drawing functions. So definitely if we decide to go for a circle, we will need some color of the circle, we will need some probably radius of the circle. So let's say for now it will be 6.0, and we will have an outline for the circle. So for that we can create a color background and say Q color will be completely solid, and let's try FF7700. The same way we can set the color of the outline. This will be color 100% solid, and we will use black. 1, 2, 3, 1, 2, 3, 6 zeros from pyqt5.qt GUI, import everything like this, and we can directly create a pen, and we can directly create a brush. So self underscore pen equals q pen, and we will use self color outline and self brush q brush self underscore color background, like this. So once we have this, we can probably define the width of the outline. So let's say outline width will be 1.0. So that means that we need to adjust our pen, and we can set width float to be self outline width, like this, And here we can go for paint function, and we can override this paint function to paint our actual circle. So painting circle. So we start off with the painter, and we will set brush to be self_brush. We will set a pen, so painter.setPen self_pen. And what we can do now, we can create we can paint an ellipse to be a circle. So draw ellipse, and this takes x and y and width and height as most of the function is expected. So the left top coordinate should be minus self dot radius, and the same for the y, self dot radius, and the width should be 2 times self radius, and the height should be again 2 times self dot radius, like this. When I press play, it crashed because there is one missing argument, and it's a node. Because we got a node and a socket, and the socket needs to have a reference to the node, which is here. Interesting. Are we able to pass the reference here or not? So we can't pass the reference to the node we are just creating here. So let's, for example, for now, let's say here will be free something, some items, and here will be another one too. And then we can go to the node, and inputs will be empty, outputs will be empty too. We can move this up to a new function. Initialize input outputs like this, and we can take inputs and outputs, and we can call self init input outputs with inputs and outputs. Or maybe doing it this way is kind of silly, so we can go for each socket or item in inputs. We can go ahead and go to the self inputs, append, and we will append a new socket for that. And the socket will be new socket, and here we can pass the reference to the node, and in this case it will be self, like this. Okay, so we need socket from node socket, import socket, like this. And it doesn't crash. Okay, so that means that we initialize here in the window the inputs with something which will be later probably replaced. So we can basically use, for example, constants like this 1, 2, 3, which will represent different type of sockets, and the sockets will be actually initialized once the node is constructed. So we will go ahead, we will create a graphical node here, then we can create the sockets. Once we instantiate the sockets, here we are creating the graphical sockets. We do have the reference to the node, so we can say the parent for this will be self node graphical node, like this. And as you can see, we got a socket which is appended to position 0, 0 of the node. Okay, but we got some error, and this is not implemented error. Graphic item bounding rectangle is an abstract and must be overridden, and probably this is because when we are painting the QDM graphic socket here, we are painting, we should probably define a bounding rectangle function like this. So this will return Q rectangle F, and we don't know that again. So from pyqt5.qt_core import everything. Now we know what the rectangle is, and here inside we can go ahead and start implementing bounding rectangle. So our bounding rectangle should be minus self dot radius. Let's take the outline width in the account. So this should be minus self dot outline width. This is our starting X position. The starting Y position will be the same. The width will be 2 times self radius plus self outline width, and the same rule will work for the height too. So if I press play now, you can see no errors. Okay, when I decide to have bigger outline for the nodes, we can have bigger outline, and I'm not able to select it on the socket and drag it around. So that's okay, that works, because either way the position of the graphical socket will be defined exactly depending of our position, if it's top left or top right, or whenever we decide to put it. So here is an index. This will be 0, and currently we are not setting the index at all. So we can go to the node again here, and when we are creating the inputs, we can create a counter. So counter will be 0, and index will be counter. After that, we can say counter plus equals 1, and then we are going to append a socket, and we need to do the same thing for outputs. So for item in outputs, let's go ahead and create a socket. The node will be self, and the index will be again counter plus equals 1, and self inputs no, outputs append socket like this. And because the output counter will start again from 0, so this is going to create sockets for inputs and outputs like this. Let's start. That works. Okay, nice. And let's change this back 1 to 1. Okay. Now let's go ahead and take care of the position. So when we are creating the socket, we are defining the positions: left top, bottom top, right top, etc. So here, when we instantiate this, we can say that the input position will be left top and the output position should be right top, like this, but we don't know this constant, so we need to import them. So from socket, import socket and left bottom, left top, and we don't need left bottom, but you know what, let's just import from node socket everything, and that should be okay-ish somehow. Nice. Let's decide where do we wanna count the socket position. Okay, so who should know about the correct socket position? Is it the socket or is it the node? I believe it should be the node. Let's implement a new function and we call it get socket position, like this, and we will pass index and we will pass position. So now we need to count for the different positions. So in case if position is in left top or left bottom, you definitely know that the x position will be 0, otherwise the x position will be the width of the node. So where do we know about the width? We actually know it here in the graphical node. Here we have the width. So the x should be self gr node dot width, like this. Okay, so that's for the x position, and the y position will be a little bit different. So we can clear this up a little bit and we can write this to one line. So let's say x will equal to 0 if the position is in left top or left bottom, otherwise the position will be self gr node width. Okay, and let's count for the y. So let's say it will be index multiplied by, let's say, 20 for now. So let's test this function. The node should have get socket position. Now here when we create the socket, we need to set the correct position to that graphical socket. So here is our socket. So we can say self gr socket set position and put x and y there. So the function we defined in node, that's here, we can say return x and y, like this. Then we can go back to the socket. Oh, excuse me, here to the socket, and we can set x and y positions here. So we can say self node get socket position and index position will be passed in, and again this will return a tuple. So we don't want that, we need 2 arguments here, so we will put a star here. Okay, this doesn't work. Position. So let's try to close it to the parentheses. Position in. Okay, and now you can see we got 3 input nodes and 1 output node. Okay, so what's this gonna be? Probably the graphics node has something like title height. Okay, so we can adjust this, and we can say self graphic node title height plus, and we can use padding too. So self gr node dot padding like this plus index. Okay, and now we start exactly here. So probably padding is not enough, so let's add self gr node edge size, and this is looking better. Okay, now we need to decide if the spacing is enough for us or not. So I will just say let's go for 30 like this. That's too much, so let's go for 24 like this. Still too much, I believe, so let's say 22. Yeah, I kinda like this. Okay, so we got a socket. We can still drag this around. Here is some issue. As you can see, we can drag the node here, which is not correct. And the reason why should be if we go here to the node, gr graphics node, the bounding rectangle should be width and height. Let's try that. Now I can't drag this, and once I click here, yeah, I still can drag it on this corner. Let's test the left one, left side. Nope, not possible, okay, and now it works. Nice, awesome. Okay, so this works, and let's try something different. So when we go to the node and we say that we want to create sockets for the input, let's say there will be left bottom like this, and now you can see these are not left bottom. So how to fix that? That's quite simple. So if our position is in left bottom or right bottom, we'll go ahead and calculate y by something. Otherwise we can use this one, because this will start from top and this will start from bottom. So in this case, when we are starting from the bottom, then we need to go and say that the index will be multiplied by this number, which is actually spacing. So let's say here we can somewhere say socket spacing equals to 22. Say self socket spacing self.socket spacing like this. Let's try it out, and it starts from 0, and we don't want that. We do want to start here. So self graphic node dot height minus index multiplied by socket spacing. So it's here. Okay, and we need to move it a little bit up. So again, as we did with the counting, let's subtract gr node edge size, which should be the bottom border. Okay, and let's just subtract the padding here too. So we are basically using the same thing. Okay, so this means these are starting now from 0, 1, 2 from the left bottom. Let's quickly test out if when we create don't need that. When we create a socket here, no, when we are creating the node, that is right top, and let's test this to be right bottom if it works. Yeah, and it works. So the inputs are on right bottom and the output is on right top, which doesn't make any sense. So let's go ahead and try left bottom and right top. We can run it again and you can see we got 3 inputs, 1 output, they are connected. We can drag this around and it works. So this is it. So thanks for watching and see you in the next part.